that you're joining in. Welcome to our tech webinar series on cloud data warehouse and data lakes with Informatica Intelligent Cloud Services. I am Vishwa Belur. I'm the Senior Director of Product Management for Cloud Mass Ingestion. Today, I'm going to talk about how you could ingest data from variety of sources into your cloud data warehouses and data lakes with cloud mass ingestion. So please note that we will not be taking questions live. So if you have any questions, feel free to enter them in the Q&A box, and we will get back to you after the session with the answers to the questions and also follow up with you. Okay, so let's jump in. So what do I have for agenda today? In the next 30 minutes, I'm going to cover the market trends and reference architecture for cloud data lake and data warehouses. And then I'll give you an overview of cloud mass ingestion and also the typical use cases it addresses. I'll share a customer success story with mass ingestion who's where mass ingestion has helped the customer to be successful with their cloud data warehouse journey. And then I will give a quick overview of various mass ingestion components, and then show a use case demo of how mass ingestion helps a customer to move data from on-prem sources into a cloud data warehouse, and then do a summary, right? So let's jump in, right? So if you see the market trends within data integration world, right? So you see that there has been a tremendous shift towards cloud, right? From the traditional data warehouses or data marts on-prem, customers are moving to cloud data warehouses for addressing new use cases, be it AI, ML, or advanced analytics, or many of the new age analytics use cases for their customers, right? And then the other key thing is the world is actually moving from ETL into ELT plus ETL, right? Which is essentially earlier extract, transform, and load was the key ask of a data integration solution. Now we are seeing get the data into a lake, and then I will use various push down and optimization techniques to massage data or integrate the data, right? And then from the warehouses or databases perspective, we are seeing the adoption to the cloud from on-prem Teradata, Netezza, Oracle, Exadata, etc., into the cloud like Redshift, Snowflake, and Azure SQL TW or Synapse or Google BigQuery, and so on and so forth. And then the new cloud ecosystems are also driving the way in which customers actually look at the data integration solution. So if you look at the type of sources customers actually ingest, right, from their on-prem sources into the cloud, be it files or databases or mainframe systems or data, streaming and IoT sources like devices, sensors, and logs, messaging systems like Kafka, and applications like SAP, Salesforce, REST API, and get them into the lake. So it's a huge challenge, and there are like variety of data sources, and it's always a challenge to get everything into the lake without having to go through a complex experience, right? So that's really a challenge that we hear from customers all the time. So what is Informatica's reference architecture for cloud data management, right? So I'll just build out this slide. So from our experience with customers, right? So customers actually take a stepwise approach for data management. The first step is to understand or discover the sources of information that they have, and then once they have that information, they can actually ingest or replicate the data from on-premises systems into the cloud on-premises or cloud systems into their cloud data warehouse or data lakes, so that they can make use of data for their analytics use cases. You see on the right hand side here the various analytics use cases that you see, be it real-time analytics or enterprise analytics or line of business analytics, which is where you provide self-service analytics capabilities for their where IT provides self-service analytics capabilities for their downstream consumers, and also data science and AI and ML use cases for their data science project or advanced analytics projects, right? So once you ingest data from a variety of these sources into the cloud data lake or replicate them into cloud data warehouse, you can make it available for analytics after the various data integration and data quality techniques that is needed in the cloud data integration solution, right? So the typical approach that customers take is to land the data into a cloud storage like a S3 or AWS Gen 2 or Google Cloud Storage, and then make it available for analytics either on their cloud data warehouse by massaging and all those techniques, or put that into an enterprise zone so that it could be used for data science, AI, and ML projects, or it could be stream processing using Kafka and many other systems, right? So that's really the reference architecture that we see with our customers. And today we are going to focus more on the data ingestion and replication part of the overall journey, right? So mass ingestion, unified mass ingestion, as we call it, is the solution that addresses the ingestion from variety of sources, whether it is streaming sources, files, or mass or databases, right? Databases and CDC, and into cloud data warehouses and data lakes with a simple and unified experience, right? So as I said, it offers a unified experience. It's a wizard-driven experience, so that you can ingest and synchronize your data sources into targets without having to go through building a complex mapping, right? Mapping or any task. It offers a step-by-step wizard so that you can design your workflow in a very simple manner and easy to use experience with very less learning curve. It helps deploy, schedule, real-time monitoring, and also lifecycle management experience for customers, and while offering versatile out-of-the-box connectivity to sources like databases and CDC sources or streaming sources or local files and cloud-to-cloud movement between using the file mass ingestion capabilities, right? So it offers out-of-the-box connectivity to the source as well as on the target side to various cloud ecosystems, be it Azure, AWS, GCP, and also the Snowflake, etc. So what are the use case patterns that it addresses, right? So there are three major use cases. The first is data lake ingestion, like the way I said earlier, right? So get the data into a cloud data lake or an object store from variety of sources, whether it is files or streaming sources or database data, essentially initial load of database data or even CDC load of database data into an object store like S3 or ADLS Gen 2, so that they can use it. They can use that for real-time or the downstream analytics, right? And you can ingest data from variety of sources, whether it is files from S3, ADLS, etc., or even FTP, SFTP, and so such sources. And the second use case is data warehouse modernization or deep synchronization use case, right? So where you would be mass ingesting on-premise database or data warehouse data, or even mainframe like DB2 I series or Z series into a cloud data warehouse, and then followed by synchronization, right? So you do the initial load, and then you do the incremental load and apply the changes onto the target, right? While taking care of schema drift, right? So schema drift is a key capability, key ask from the customers that where the source schema changes and the system needs to be efficient to address that automatically without having for the customers to stop and restart their flows, right? And it supports data from ingest data sources like Oracle, SQL Server, MySQL, Teradata, DB2, and Postgre, and also onto targets like S3, Synapse, Snowflake, ADLS, and GCS. So the third and not the last but not the least is the real-time analytics use cases where you get the data from log files, click streams, etc., and CDC and IoT into into cloud data lakes or into uh, uh, messaging systems like Kafka, so that you could use it for downstream real-time analytics. So I would like to cover one example of one of our customers who was very successful in migrating to the cloud. We have University of New Orleans which increased student enrollment and improved retention of students using the mass ingestion solution, right? So their use case was to accelerate their data warehouse modernization from Oracle to Snowflake, and they were able to migrate thousands of tables, right, and with complex data structures from Oracle to Snowflake with no hand coding at all, and which reduced their manual ETL effort by up to by 90%, so that they can use their capacity or IT capacity for various other use cases, right? And why they selected Informatica? Because Informatica helped them to extract, transform, and load data into Snowflake, as well as using the traditional data integration technique, as well as help them using the wizard-based approach of mass ingestion to reduce their time of movement into the cloud, right? So they used it for initial load, but they plan to use they've actually started to do the incremental CDC load, and also from variety of other sources as well. So this was their architecture. It's quite simple. So they have their ERP systems and databases that they brought into cloud data warehouse. They are like thousands of, they have like 12,000 tables that they moved into Snowflake using cloud mass ingestion, right? Which they use it for their downstream analytics use case. So mass ingestion has actually three components, right? So the first is the mass ingestion databases, right? And all of them, note that all of them offer a very simple, four-step wizard-based approach for you to ingest data from ingest and synchronize data from on-prem sources into the cloud, right? So mass ingestion databases helps you to ingest data from databases, data warehouses, and also mainframe systems into the cloud targets like cloud data lakes or data warehouses, and also messaging systems like Kafka and Azure Event Hub, right? So essentially, you can synchronize the data from on-prem sources into the cloud, or you can load the incremental CDC into a messaging system so that you could use it for real-time analytics. And some of the use cases with chain data capture. So I talked about incremental CDC load, which means that the chain data capture or CDC is one of the key use cases, right? So whether it is data synchronization in real time, replication as we call it as, or real time data lake ingestion into the cloud, or real time streaming analytics are some of the use cases that we are seeing with chain data capture, especially the last one, streaming analytics for fraud detection and on the transactional system, etc. So, what are the various types of cloud data change data captures that we've seen in the market, right? So, one is logminer CDC, which is a relational interface for redo logs in Oracle, which you could use for capturing logs, and a timestamp based CDC, which would help you to capture changes from DB using timestamp. And the last two are based on logs, right? So the first one here is logs or SQL, where it provides you use a SQL query on logs to extract CDC. You don't need the physical access to the log files in that case. And there are some, it's a very simple mechanism to extract CDC. And log-based CDC is the preferred approach for Informatica, which is used both in mass ingestion as well as for Exchange products, where you will be extracting logs from the DB logs files, which is the most efficient method of accessing CDC, and it scales very well for higher volumes. And for the use cases where customers have lower volumes, and also the places where we cannot really access physical log files, we support logs over SQL as well. So mass ingestion streaming is our is the other capability within mass ingestion, which would help you to ingest data from streaming sources, either into messaging systems like Kafka for real-time analytics, or into data lake for machine learning and consumption use cases, right? So we support variety of sources, whether it is JMS, Kafka, logs, API sources, Google Cloud, Google Amazon Kinesis, Azure Event Hub, and many other connectors that we support. And finally, mass ingestion files, which would help you to move data from your on-prem sources, on-prem file sources into the cloud data lake for our data warehouse for consumption, or even cloud to cloud movement. For example, Azure AWS S3 or Amazon S3 onto ADLS Gen 2. Such use cases can also be solved. Essentially, cloud to cloud, ground to cloud, and cloud to ground use cases are solved with mass ingestion files. So now let me actually quickly show a demonstration of how you could use mass ingestion for migrating data from Oracle into Snowflake using mass ingestion, where you can see initial and incremental CDC load from Oracle into Snowflake. So we do the bulk initial load first, followed by incremental CDC load, and also handle schema drift at the source, right? Let me just flip over to the demo. Let me just give me a second while I set that up. Okay, yes, I'm ready now. Okay, so here is my Informatica Intelligent Cloud Services instance, right? So in one of the pods. So what I do is I'll actually log into my server, right? And my instance here, right? So I will. Okay, so it shows all my services, right? So you see variety of services here, whether it is data integration, application integration, integration hub, and many others, right? So I go to the mass ingestion part, which is where I will be showing the demo, right? I click on it. It takes me to the home page. I can click on new here, right? And then see the variety of file systems or file sources that it supports, whether it's databases, file, or stream, right? So you see here that you can click on any of these, and all of them have a simple wizard-based experience that I actually speak about, show in a minute, right? I can click on a database ingestion task. However, I've already created a task that I'm going to demonstrate, right? So I click on my folder where I have actually my Oracle to Snowflake synchronization, right? I come here, and you see the step-by-step wizard, right? So we have there's a definition of the task. Here is my source, here is my target, and some runtime options, and you should be ready, right? So I've chosen my runtime environment, or the security agent as the engine on which it's going to run. I provide a description here, and then I can choose the type of load here, right? So whether it is initial load, or incremental load, or initial followed by incremental load, right? So which is essentially what we call as combined load, where we would be keeping a snapshot of the database while we start our initial load, and then once the initial load is complete for all the tables, then we will start the incremental CDC load, and then applying the changes automatically, and also the schema changes, which I will come to in a second, right? So okay, so I'm good with this, right? So then I go to my database, right? So I create, I choose my connection here, and then I select my schema, and I have the table count, right? So you can actually add your own rule for selection, table selection, which means that you by default we will be including all the tables in the schema, but you can include, like for example, I've included all the temporary tables, right? So you can do a table count as well if you like, or add your own rules, and create your own or edit the rules as well, that is already defined automatically, right, out of the box. So you can also choose advanced, where you can choose, given that it's a CDC load, we can choose the restart point for the incremental CDC load. I'm going to choose the default, but there is various options, whether it is latest or a custom position, or the specific date and time, right? So, and then that's all about the source. On the target side, I created created a Snowflake connection that I've selected here. I create tables automatically at the target. So you don't need to manually create them at the target. If there are like 10,000 sources tables, source table, so we automatically create target tables. Right? So and then you can select a schema as well, and you have to define a staging area where the data gets landed first before it gets applied into the target. Right? So you can even have a set of rules for renaming a source and target table. For example, in this case, what I've done is all the tables I am actually prefixing that with ABQA, right? So that's my rule. And all the tables at the whichever that you find in Oracle, they will be prefixed with ABQA at the target side, which is on Snowflake. All right, so here is where things get interesting. So I can define what happens when there's a schema change, right? So I mean we support various schema changes, right? Whether it's add column, modify column, drop column, and then rename column. So you can define what do you want to do with each of those actions, right? So whether it is you can ignore or replicate, which is the default option, or even stop the job. If you find a schema change, you can say that I want to stop the job, or stop the job for only this table. Right? That's something that you could do as well. Right? So then, yeah, that's it. So basically, within a four-step wizard, I created a job which would continuously synchronize from 10,000s of Oracle tables into Snowflake. Right? So that's it. So I can actually save it. It's already saved anyway, right? So and then deploy that, right? It's deployed already. So and then I go to my jobs, right? Uh, Essentially, since I made some changes, it applied that, right? And I deployed that, so I can go to my jobs page on the monitor, right? So here is where it is going to come up, right? So this is the typical developer persona, right? So where you are a designer persona who would define and test it out and make it ready for the production. So let's say now how you will monitor at the production instance, right? So I go to the application switcher, and I select my monitor, right? So I go to this is a different. I mean, this is where actually the operator persona would manage or see how all the jobs that are running within the organization, within their org, right? They can see it here, right? So then I go to mass suggestion here, and this is where it shows me all the mass ingestion jobs that are running within your org, right? So I have three streaming jobs and 2,900, close to 2,900 database jobs, and I haven't created any file jobs, right? So I can select on the database job, and it shows the jobs for only the database, right? So you can even click on the ones which are running with error or running with warning, and even we have some of the capabilities where you could select jobs requiring attention, etc. So then in this case, given that I'm looking at the jobs which are up and running. I click on that, right? Um, and I see, I can see failed jobs here, right? So jobs requiring attention, as I mentioned earlier. So you can see the jobs with warning and failed status, right? And then I come to the jobs which are running with up and running, right? So then I choose Oracle to Snowflake, which is the job that I just triggered, right? It has 100 tables, and all the 100 tables are running, and you can see the overall status of the job, whether it's up and running, how many records it has read, and when did it start. It's actually running for a long time, right? So it's almost more than a year now, right? And then you can go to the object details and see the detailed status at each table level, right? So if there are 10,000 tables, you can actually scroll down, or go to the pages and see at each table level, right? So I click on this table. I see that there is the job is running, and it's counting the number of changes that are actually happening. I can do the same for all the tables, right? Or you can actually see the overall status here in terms of how the job is running. If there are any alerts, you can actually see it in the alerts tab. And we also have the capabilities to notify in case of errors, or in case of any issues with the job. You can actually see it in the as an email alert or as a system alert. Yeah, that's pretty much I wanted to show on the demonstration. So let me go back to my slide. So as you see, I showed the ingestion, or we call it synchronization from on-prem database into a cloud data warehouse in very simple step-by-step wizard, which would help you to synchronize initial and chain data from thousands of DB tables onto cloud data warehouse for reporting and analytics use cases. So as you saw, the benefits of cloud mass ingestion, it's a single ingestion for all patterns, so that you can make use of it for all the ingestion patterns without having to go through multiple solutions. It's a wizard-driven experience, so which increases business agility. You can efficiently ingest and CDC from thousands of tables. It automatically addresses schema drift and also provides edge transformations, out-of-the-box connectivity to a variety of sources, whether it is file, database, CDC, IoT, and streaming, and it offers real-time monitoring and alerting capabilities so that you can troubleshoot any issues much faster. So in summary, mass ingestion provides cloud native ingestion capabilities, and it offers out-of-the-box connectivity. It offers a wizard-driven design experience and real-time monitoring experience. All right, that's all I had for today. We have a free trial of mass ingestion, free 30-day trial of cloud mass ingestion that you can go to the informatica.com and sign up for it. And also here are some of the materials that you could use for learning more about mass ingestion. Okay. Thanks a lot. I know we are on the top of the hour. Thanks a lot for joining in today, and we would look forward to see you during our next part of the series on the next Thursday. Thank you so much. We will answer your questions and follow up with you separately. Thank you and have a great day.